Hello and welcome to this Malden presentation and demonstration of the MultiDSLA speech quality test system with the new advanced SIP client VPP Plus. VPP is Voxport Packet. This client may be thought of as a reference SIP phone. For testing purposes, it makes and receives SIP calls either between other similar clients or with other SIP entities. It may work with or without a SIP server. One of the really advanced things and interesting things about this client is that it's capable of producing packet impairments which may be random or may be synchronized very precisely to the speech signals which are being used for testing, or indeed may be taken from a packet capture. So it's really very flexible in that respect. Another great feature that it has is the ability to manipulate AMR codec rates so that the TX rate can be changed and codec mode requests, CMR, can be made to the far end of the network. Now I've switched to the MultiDSLA controller, and here, as you can see, the VPP clients are represented by these blue colored dots or nodes in the control system. And what we can do is to have these call each other, or have VPP1 call VPP2 by dragging and dropping a line over there. What you may be able to see in this area now is some of the SIP transactions showing that the call has been set up, and the blue dotted line which progresses across the screen represents the real speech file, a WAV file originally, which has been encoded and transmitted as RTP across the network. The green line suggests that we have a relatively good speech quality score for that, but we can double click and investigate in a little more detail. We see first of all the auto call setup information. This simple ladder diagram shows us in some detail about the SIP transaction setting up and clearing down the call, and the speech quality analysis is available in the next view. And here we can see that we're using the very latest version 2.4 of Polka, and it has returned a score of 4.28. This, by the way, is using the highest bit rate of the AMR codec in the wideband mode. The Malden representation here shows the perceptual energy of the speech signal, the top one being the reference signal which we used to play out into the network, and the second one here, which is the degraded signal, the corresponding degraded signal. After PESC has processed, or Polka in this case, has processed these, the difference between them here, the error surface, represents the audible errors. And I should have mentioned that we have a time scale running along here horizontally, and we have perceptual energy in all cases on the vertical scale. Now let's see what happens if we introduce some impairments into that process. I'll do that here by activating the packet impairment mode, and let me show you this profile which we've set up here called packet impairment 1, and let's edit that. So we can see in the top trace the waveform of the speech file, the reference speech file, which we're using for the testing in this case. It's a female voice. It has two sentences in the classic sentence pair structure, and you can see that synchronized with that we have here some packet loss, 4 consecutive packets lost at that stage, and some jitter which we've introduced deliberately towards the end of the first sentence. Now we can view that in a little more detail by using the zoom facility, and now as I click on here you can see that that's packet number 124, 125, 126 and 127. So 4 consecutive packets are going to be dropped there every time we use this profile, and over here we have 4 milliseconds of jitter at packet 142, and then some other packets here also affected by jitter to varying degrees after that. And apart from that, if we go back to the full view, there are no impairments for the rest of the 8 seconds that this measurement will take. So I'm going to close that window, and then let's try running that. I'll clear that summary away first of all. Let's run that test. and see what result we get this time. So the call is being set up in the same way as before. The speech signal then comes out from VPP 1 across to VPP 2 through the network with the impairments in the packet stream as that happens. And this time we have a yellow line indicating that the quality is not quite as good as it was last time. Once again, the ladder diagram, but what we're really interested in here is the speech quality analysis, and see how the score has plummeted to 2.92. And you may be able to see just here in this area where the error surface is a little more pronounced, and that is exactly around the time that the 4 packets have been dropped. Incidentally, we still use the legacy speech quality metric PESC. One of the reasons for that is that visually it does give sometimes a rather more useful, a rather more pronounced display of what's happening, and here we can see in this case that certainly is so. We can see a little break here in the degraded file corresponding to those 4 packets, so the reference signal is intact at that point, and we can see that there is missing signal there showing up as an audible error at that point around just over the 2.5 second mark. Okay, so let's now go back to the task list and let's change that packet impairment back to inactive, and this time let's make the rate change overlay active, and I'll show you in a very similar way what this is doing. You may remember a few minutes ago I mentioned that we can change the TX codec rate, that's the transmit codec rate, which VPP1 will use, and that's the blue line on here. So it will start at rate 1, and at precisely 4 seconds, again remember this is synchronized with the test signal that we're using, it will switch to mode 8, where it will remain for 2 seconds until we reach 6 seconds, and then switch back again to rate 1. I'm not using the CMR in this case, the codec mode request, but you can see here that I could program that in a similar way to make requests of the far end for the rate to be used. So I'm going to close that and clear that summary and run this third test in the same way. Once again, the call is being set up. The speech signal is being transmitted from one end to the other, remember with the codec rate change incorporated. This time we have a green line once again. We're not so concerned with the call setup information, but we are interested to see. Let's look first of all at the Polka score. It's 3.97, so somewhere between the 2 previous scores. We have these rather convenient markers to display exactly where the rate change took place. So we were at the 8.85 kilobits per second rate right up until the 4 second point, and then between 4 seconds and 6 seconds, as you may remember, we switched to the 23.85 kilobits per second rate, and then we drop back to the 8.85 rate again from 6 seconds onwards. Now, what can we see in the error surface here corresponding to this? Well, we can see that the errors around here, just about possible to see that they're of a lower order than they are here or at the beginning. And again, if we switch to the PESC view, we may see that a little more clearly. I think we do. Here we have this fairly consistent shape of the errors, and then when we are using the faster codec rate, which should be more efficient in terms of the quality of transmission, we see that the corresponding errors there are rather of a smaller order before reverting again at the 6 second point to the rather fatter shape that we see over here. One other thing we can do with this is to replay the signal, which is usually quite interesting, so let's do that now.
These days, a chicken leg is a rare dish. The hogs were fed chopped corn and garbage.
So that's the end of the demonstration. I hope you found that interesting, and do contact us if there's something more that you'd like to know. Thank you very much for watching and listening.